Hello, my name is Clarice Hilton and I'll be presenting InteractML, making machine learning accessible for creative practitioners working with movement interaction in immersive media. This has come out of the 4i project, which has been a joint research project between Goldsmiths University, University of the Arts London, Coventry University, York University and artist studio Gibson Martelli. So movement-based interaction is becoming increasingly popular in performance and artwork which is in VR, as movement sensor technologies such as hand tracking and body tracking are becoming more accessible. These sensors now come as standard with many VR headsets. The artwork behind me is Mutator VR's Vortex. Through movement interaction, users can mix characteristics of the virtual environment, including abstract shapes and sounds. This piece was created by William Latham alongside mathematicians and programmers Stephen Todd, Lance Putnam, and Peter Todd. Movement interaction in VR can be incredibly beneficial, as you're able to create intuitive embodied movements in VR to affect the environment around you. This can cause increased presence through these sensory motor contingencies that you experience. And this reality-based interaction style can create a more immersive experience. It's also been shown to increase focus and attention, as well as emotional engagement in the work. However, even the most simple interaction can be incredibly difficult to implement and may need machine learning. This can be very difficult and needs expert knowledge, which not all artists or dancers or indie games developers may have. Furthermore, compelling interaction is also really difficult to design. And also many movement interactions can be difficult to learn inside of the VR if it's something you're not used to doing. This can have a negative effect on immersion. This is where interactive machine learning can come in. Interactive machine learning allows users to choose types of data for training set, record or provide examples of the data, and pair examples with a label to input into an algorithm, then test to observe the output of the system, iteratively editing the setup to produce the ideal result. In movement interaction, this could allow creators to capture complex movements simply by performing them to the system. These performances provide the system with movement examples that form the training set. The movement training set is used as an input to the machine learning algorithm, and the algorithm learns to recognize those performed movements. Each movement example is paired with an output value by the creator. So one movement, for example, if I start with my hands to the side of my face and rotate them inwards so that they're end with the tips of my fingers facing each other, I could label this blue or 1. Then another movement, so if my hands are starting facing with the fingers facing each other and the back of my hands facing outwards, and they rotate so then the fingertips are facing towards the sky, this could be labeled 2 or black. The system can then recognize those movements through a live input into the system. So there's a live input of data showing that I'm doing the first action or the second action. The system can then recognize those movements and give the appropriate output. This output can then be used to trigger anything in your scene or drive anything. Interactive machine learning allows for designers to bridge the gap between ideation and implementation stages, whilst offering all the benefits of exploiting our tacit embodied knowledge in the design process. This melds together ideation and implementation. So this is why we decided to create InteractML. InteractML is an interactive machine learning tool for movement design, specifically for dancers, artists, and indie games developers. It's a node-based design, and you need as little as 7 nodes to be able to make a working graph. It's input agnostic, so any sensor input could be used or as input or any other values. However, we've designed it specifically with VR in mind. And therefore, we also have, as well as the node-based system, we also have a VR interface, which allows you to record examples and observe the output whilst inside of the headset. The idea behind the tool is that we want to create a working understanding of machine learning so that users can use it to implement their movement interaction design, but it doesn't necessitate a deep understanding of the algorithms behind it. Our design approach is interactive and experimental and has a sense of play. We want the playful nature enables people to take risk in their movement interactions. They can rapidly and easily refine their movement interaction designs based on the feedback that the system is giving. So alongside the tool, we've also developed a movement ideation theory and methodology on how you develop your movement interaction ideas. So here's a little bit of background to that. So SOMA design approach embraces the effective and embodied dimensions in the design process. The approach suggests a framework for designing bodily-based interaction based on SOMA aesthetics. The approach encourages a slower process that is actively reflective of lived embodied experience and the tacit understanding of movement and interacting. The approach is also inspired by Sheets Johnson's insight on the primacy of movement, that movement and emotion are expressively interdependent, and draws from the ideas of the field of effective computing. And in our process, we've been doing something that we call body storming, which is a practice of designing movement and acting them out. Following from Karamu et al., our method uses an adapted form of the critical incident technique, a procedure that elicits designers to recall a recently lived memory from their everyday lives and apply it as input for design. In our process, we get people to think of something or a movement that they've done in the past 24 hours that is in some way interesting or different. We then get them to match this with a superpower and then get them to change the movement in certain ways, making it bigger, smaller, faster, slower, go wrong. This play enables people to really reflect on themselves and take risks without dwelling on the outcomes. We've used a user-centered design approach, running workshops, hackathons, and residencies. This has involved the movement ideation workshop and the body storming, followed by learning about the tool through tutorials and exercises, then on to prototyping and presenting their work back. Insights from the interviews and observations are fed into the design of the tool. We've iterated on how the tool works and what features we've implemented in it through outcomes of these workshops. Originally, these workshops were going to be done all in person, but of course it's been during the pandemic and we've moved them all online. This has been a really interesting experience, as it's meant that we've done these ideation sessions in VR. In the image behind me, you see a workshop that we ran in Rec Room. So the way we've also done a longitudinal study, so that was the residencies where we had artists work with the tool for 3 months. And this gave us a greater understanding of how the use of the tool develops and how the understanding of machine learning and how to use the tool develops over time. Many of the artists continue to use InteractML in their work, which has been a great outcome. We've also observed a cross-pollination of ideas, where as well as their ideas feeding into the tool, using the tool has also affected the design of movement that they've implemented into the system. So as well as iterating over how to design the setup of InteractML, that has also affected their iteration on how do they design their movements. Thank you so much, and I really look forward to your questions.